Okay, if you'll remember from our last video, we talked about how air moves from high pressure to low pressure. So here I've drawn in the high pressure in the cold polar region and the low pressure at the equator. So let's start up here. Let's do the polar cell. So the air is moving here from an area of high pressure down to an area of low pressure, right? But it doesn't quite reach the equator. It gets too warm right at about 60 degrees north latitude, and it starts to heat up. As it heats up, it moves away from the Earth. It rises away from the Earth. And then more air comes to fill in that space as this is rising up, and this causes this cell. So this is called the polar cell. This is the first convection current that we're going to be looking at. As it cycles back around, you've got a convection current, and then notice just how as this moves along, more air has to come in to replace it. So more air comes in to replace here, back and forth, and goes all the way around. The same is going to be true at the southern hemisphere. It's moving from an area of high pressure to an area of low pressure, but then it heats up, rises, and then circles back around. Again, that would be the southern polar cell. So let's look at what would happen at about 30 degrees north. At 30 degrees north, it's considerably cooler than at the equator. So it's going to still move from this area of higher pressure to lower pressure. And then when it reaches the equator, it's going to get very hot very quickly and start to rise. And then it's going to circle back around to make this convection current here. Sorry, it's not very neat. And this will be called the Hadley cell. And again, the same thing is going to be happening here as it moves toward the equator. And then as it hits the equator, it's going to move up. It's going to rise because it's getting warmer, and then cycle back around as it replaces. Again, Hadley cell. So notice that everything is mirrored right at the equator. So if you were to fold this in half, the southern hemisphere would mirror the northern. Okay, so now see here at 30 degrees. Let's look at actually 30 degrees north. What happens in here? Well, what's really interesting in here is that as this air is moving up, away from the atmosphere, up into the atmosphere, and as this is moving down, it actually takes some other air with it. So this is going to follow the air that it's kind of neighboring, and same with here. And then as this comes down to the Earth, it's going to fill in where this has left, and then this is going to fill in where that has left. So this is the Ferrel cell. It's two L's. And the same is going to happen here. It's going to kind of pull the air with it, causing another current, but this convection current is not dependent on the heat. It's really just kind of sucked up into the ones on either side of it. It's created because of the other two. So this really affects the global wind patterns. So let's look in the northern hemisphere at what happens in the north. So remember our car in the last video, it started in the at the North Pole, and it was traveling to the equator. However, it started to move to the right. And that's what's going to happen here. These winds are going from high pressure to low pressure. So you notice this arrow here. This is obviously a 2D drawing of a 3D situation. So it's wanting to move down, but it's going to go off to the right. And that's due to the Coriolis effect. So it's traveling from the east to the west, And we always name winds by where they come from. So these are called the polar easterlies. All right, in the southern hemisphere, again, we have winds that are going north, and since they're in the southern hemisphere, they turn to the left. But these are still going from the east to the west, so these are still called the polar easterlies. Okay, so now here at the equator, between the equator and 30 degrees north, the winds blow towards the east, right? So we've got the Hadley cell here. Let's pick a color. The Hadley cell says that the winds are going to be moving from here to here, but they're going to go this direction because of Coriolis effects. And again, they're going to the east, right? And these are called the trade winds. The trade winds it was important when ships were used for trading, and they had big sailing ships, and they were coming from Europe and trying to get to South America and that kind of thing. So the trade winds helped them to get through. Same is true in the southern hemisphere, except for those go to the left. Notice that they still go this way though. Right, let's maybe do one more right here. And these are still the trade winds. Okay, what about these mid-latitudes? A lot happens in these mid-latitudes. We live in this mid-latitude, right? Between 30 degrees north and 60 degrees north. Most of the US, in fact, is in this mid-latitude here. So the Ferrel cell tells us that the wind wants to go from 30 degrees north to 60 degrees north. But since it's traveling north, and it's in the northern hemisphere, it's going to be turning to the right. So it's going to look like this. So strange, right, that it's so opposite than in the two on the opposite sides. And since these are traveling from the west to the east, they are called the westerlies, and in this case they're called the prevailing westerlies. And I'll talk more about why they're called prevailing in a little bit. So the weather in the US, predominantly because of these prevailing westerlies, the weather in the US moves from the west coast to the east coast for this reason here. And the same is true in the southern mid-latitudes. The wind is blowing south based on this Ferrel cell here, but it's going to be turning to the left. And these are still coming from the west, so we're calling them, again, the prevailing westerlies. All right, a few interesting things to add to our picture here. An interesting spot here. What do you think would happen if you were in a boat right here? Where would your boat, your big sailing boat, what would happen? Well, it could just sit there, right? You could be stuck there for a very long time. And sailors used to call this the doldrums. They'd say, oh man, we're really in the doldrums now, because they could get stuck there for a really long time. Another place where sailors used to get stuck was right here at 30 degrees. Draw another terrible picture of a boat. And again, they would get stuck here because there's no wind right in this line right here because the winds are going in opposite directions. And this, strangely enough, is called the horse latitudes. And the reason for that is because English traders used to have largest amount of horses on board, mostly because they were trading them with other countries. And then when they got stuck here, and they could be stuck here for weeks, months on end, and they'd start to run out of food, and they'd have to throw the horses overboard to save the weight and also the grain consumption. One more really cool thing that happens at about 60 degrees north, and this is where we'll get into what these prevailing westerlies meant. Notice that the polar easterlies and the prevailing westerlies, they're going to be butting heads right here, right? See how they're just going to bump right into each other? So we've got a very cold, very high pressure wind coming this way, and then a very low pressure and very warm air coming this way. It creates a wind that moves from west to east, and it's going to actually it's not a straight line really. We call this the polar front here, that at the top half of it is called the polar front. Probably heard that before on like Weather Channel or something. And this here is the jet stream. The jet stream moves very fast. It's about 200 miles per hour. It can be up to 200 miles an hour. And it moves from west to east. Now, why would it move west to east? It's because these prevailing westerlies, they are prevailing over the polar easterlies. Can think of it as this low pressure air that's moving already. This low pressure air that's moving from west to east. The high pressure air is kind of chasing it. The high pressure wants to get to the low pressure, so it is kind of chasing it along this. Airplanes try to get into the jet stream to save fuel and to go faster. Pilots have special instruments to try to get them into the jet stream to make it to save on fuel and to make their trips shorter. Okay, there you go. These are your wind patterns for our Earth.